Hi there! Let's determine the standard form for an equation of an ellipse. Before we could give the standard form for an equation of an ellipse, we need to be guided on what is its actual form is. There are two different forms for an equation of ellipse. The first one is when an ellipse is centered at the origin, while the other is when it is not. So the first form is with the use of this x squared over a squared plus y squared over b squared is equal to 1. This is the form for an equation of an ellipse centered at the origin. This will only be different in its position, whether it's stretching horizontally or vertically, as to where we could see A or B. Take note, the value for A is always larger than the value for B. So if it's like this, A, which is the larger value for B, is placed on or placed as a denominator of x squared. This is in the form of an ellipse stretching to the horizontal line. If we're going to rewrite it in such or interchange the two values, where a squared will be the denominator of y squared, the ellipse is still centered at the origin, but it's now stretching up. The other form for an equation of an ellipse is where it is not centered anymore on the origin. So it will become x minus h, the square of it, over a squared, plus you have here y minus k squared over b squared is equal to 1. Again, this is still stretching on horizontal basis since a squared is placed as the denominator of the expression with x. If we are going to interchange them, it will be the other way around. The center now is not at the origin. The center is at h and then k. But the similar thing between these two forms is on the hand side of the equation. The right hand side of the equation is equal to 1. So to determine the standard form for an equation of an ellipse, our first goal is to make sure that the right hand side of the equation will be equal to 1. Let's start with number 1. Here, the right hand side of the equation is 4. So for it to become 1, let us not subtract 3, okay? We're going to use the process of division. We're going to divide this by 4. And the property of equality tells us that if we're going to divide this side by 4, divide also all terms on the other side by 4. So this could become x squared plus 4y squared all over 4 is equal to 1. Again, it now meets the standard form for the right-hand side. But we are not yet done with the left-hand side since we need to show it either in this form or yung interchange ng A and B, or the other form here where the center is not anymore the origin. What we could do further here is the use of the idea 2 plus 5 over 2, which means that we could just simply say 2 over 2 plus 5 halves. This is where we share the denominator to both terms of the numerator. So we have here x squared over 4 plus 4y squared over 4 is equal to 1. We can still simplify this and that, and definitely the standard form for the equation of this ellipse is x squared over 4 plus y squared over 1, or you may not write it, equal to 1. This is the standard form for number 1. Again, the process that we did here is we divided the right-hand side with the equation by a number that could make this side equal to 1. In this case, it is 4. We will use this later on as in practice exercise B, where we are going to determine the parts and important points of the ellipse. But let's proceed to item number 2, as our goal is also to determine its standard form. Similar to number 1, our goal is for the right-hand side to be equal to 1. Hence, we will divide this side by 18 and do the same thing for the other side as well. So this will be equal to 9, sorry for that, 9x squared plus 2y squared all over 18 is equal to 1. 18 over 18 or 1. Then share the denominator here. 9x squared over 18 plus 2y squared over 18. All right, that's 18. Sorry, 18 is equal to 1. And then simply simplify this. You have 9 divided by 18. That's 1 half. So you still have 2 in the denominator. And 2 over 18 is actually 1 over 9ths. So you still have 9 in the denominator. So the standard form for an equation of an ellipse for number 2 is x squared over 2. Again, 2 is what is left here. Plus y squared over 9 is equal to 1. So this is the standard form for number 2. If we are going to compare 1 and 2 to these forms here, we all know that the center for the ellipses for number 1 and number 2 is at the origin, since it follows this concept here. Doesn't have other terms here, just like x minus h and y minus k. So it is now centered at the origin. The only difference between these two forms is that for number 1, again, we could write this as all over 1, just like this one. And we can notice that the value below x squared is larger than the value on the denominator of y squared. This means it follows that this is your a squared and this is your b squared. Okay? If that is the case, definitely a squared is bigger than b squared. If that's why 4 is a squared and 1 is b squared. Well, if that is the case, this ellipse is actually with center in the origin, but stretching horizontally, because the value for a squared is placed as the denominator of x squared. For the second, it's the other way around. It's now interchange, so it doesn't mean this is still a squared. Okay, it would be the other way around because a squared is still bigger than b squared. This is your a squared and this is your b squared. If this is the case, the value for a squared, which is 9, is under or the denominator of y squared. And this would mean that this ellipse is stretching vertically rather. But anyway, that's not the part, the concern of this practice exercise. I'm just mentioning you to that one because in the next practice exercise, we shall determine the different important points and parts of the ellipse, and soon we will know if this is really stretching horizontally and this one is vertically. Again, the goal here is to make the right-hand side equal to 1 and use the concepts of division of polynomials. Thank you very much. See you for the next video. Goodbye.